Right now we're going to start with our stoichiometry notes. So we do a lot of math in this unit, a whole lot of math in this unit. It's probably our hardest unit of the whole year. So if you survive this, then things should get easier. So stoichiometry is a proportional relationship between two or more substances in a chemical reaction. That relationship exists between moles, grams, which is really what we're going to be doing, volume, we'll do that during gas laws, and atoms. So stoichiometry is the study of the amount of substances that are consumed and produced in a chemical reaction. So it's a pretty realistic practice that would be used like at chemical plants where they're trying how to economically make the most money. You must always start with a balanced equation because the coefficients are very important in this. So the mole ratio, which is what we use our coefficients for, is the basis for all stoichiometry problems. And it will always come from a balanced equation. Y'all think a balanced equation is important? It is. I've mentioned it a bunch of times. It is the mole ratio is a conversion factor that we will use. And it's going to relate the moles of my known to the moles of my unknown. We use conversion factors in this process. It's called, the process that we do is dimensional analysis. And we have done it before, but it was back in first semester. So a conversion factor, you don't have to write this. We all know that 12 inches equals 1 foot. That's a conversion factor because those two things are equal to each other. They have different units, so they look different, but that would be considered a conversion factor. I could write it like this, or I could flip it to 1 foot over 12 inches, and it would still be true. So this is the same thing. So a conversion factor has things that are usually in different units, one over the top of each other. And that's what we use a lot in what we're doing today. So a balanced equation gives you the mole relationship between substances. The coefficients, COEFFICIENTS. I think that's how it spells it. Maybe misspelled, but I won't take off for y'all spelling if I'll take off for mine. So the coefficients tell us how many moles of everything that you have. So that's why you have to have this balanced equation. So if I have this equation right here for ammonia, NH3 is ammonia. It takes nitrogen and hydrogen to make ammonia. Those coefficients tell me how many moles I have of everything. So I'm going to kind of write that off to the side. So I have 1 mole of nitrogen because the nitrogen doesn't have a coefficient, so we assume it's 1. I have, for hydrogen, I have 3 moles of hydrogen. And for ammonia, I have 2 moles. It's kind of like a recipe. This tells me that I have to take 1 mole of nitrogen, 3 moles of hydrogen, and I combine them, and that'll give me 2 moles of ammonia. Like a cookie recipe. I have to take 2 cups of sugar and 3 cups of flour and 1 cup of butter, and that'll give me 2 dozen cookies. So it's kind of a recipe like that. All right, so we're going to start off with some questions that you can get directly from the problem. How many moles of ammonia are produced from 3 moles of hydrogen? That's exactly what I have in this problem. I have 3 moles of hydrogen. How many moles of ammonia was that able to produce? Here's my 3 moles of hydrogen. How many moles of ammonia did that produce? 2. Next one, I have 1 mole of nitrogen, which is what I have in my problem. How many moles of hydrogen does that react with? 3 moles. Perfect. So that's kind of the easy ones. I can get them directly from the problem, but of course they're not all going to be that easy. We're going to have to do a little bit of math with them. So today, not too much math. All right. So the first problem, these 2 problems, we're still using this equation. It says how many moles of ammonia are produced from 2.5 moles of nitrogen? Well, I can't look at that equation and read that directly. I'm going to have to do a problem, and we're going to be using dimensional analysis, which is whenever we use those boxes. Did y'all remember when we did that last semester? So on this particular problem, my given is in moles. My unknown is in moles. So this is a mole to mole. Woo! Just lost everything. Let's try that again. So my given is in moles. My unknown is in moles. So this is a mole to mole problem. And it takes 2 steps, which means 2 boxes. Whenever you're doing this, and like I said, it's been a while since we did it, you always start with what you're given. So I'm given 2.5 moles of nitrogen. We're not going to be putting anything in that box right there below the given. And then you end at the top closest to your equals with what you want to figure out. I want to figure out moles of ammonia. So I gave myself my beginning and I gave myself an end. Then you have to follow your units. If your moles of nitrogen here, I have to have the same unit down here because I need them to cancel out. So once I do that, I need to get numbers to put here. It's mole over mole. So anytime I have mole over mole, that's when I use my coefficients. So I'm going to start here, mole of nitrogen. How many moles of nitrogen did we say we had in this problem? There's nothing in front of nitrogen, so what do we assume it is? 1. How many moles of ammonia did I have? The NH3. I'm just reading 2. I'm reading coefficients right now. When you do this process, you multiply across. So I'm going to do 2.5 times 2, which is equal to 5. And you divide by anything on the bottom. In this case, I only have a 1 on the bottom, so it wouldn't change anything. This unit cancels out. I'm left with only moles of ammonia, which is what I want. So my answer would be 5 moles of ammonia. I did 2.5 times 2, gave me 5. I divided it by what's on the bottom. In this case, it's just 1. So that didn't change it. So that's how I got my answer. Your units come from right there. So today your units for everything are going to be moles. Remember to always start with a balanced equation. All right. Let's move down here to some of these other examples where there's a little bit more room. We'll look at these and then we'll look at some of y'all's work today. Okay, example 1. That's supposed to be an arrow where the box is. N2 plus 3. It's the same 2NH3. So it's the same equation that we've been looking at. How many moles of ammonia, so that's my unknown, are produced when 0.6 moles of nitrogen react? So 0.6 moles of nitrogen, that's my given. I'm not worried about hydrogen. And what we're doing right now and for the next few days, there could be 3 things in equation 4 or 5. We're only looking at 2. So if it helps you figure out what your given is, figure out what your unknown is, and then cross out what you don't need. My given is in moles, is 0.600 moles, and my unknown is in moles. So this is just going to be 2 steps. So I'm going to go ahead and get myself all set up. Start with my given, which was 0.600 moles of nitrogen. End up here at the top with what I want to convert to, which is moles of ammonia, NH3. I follow my units. Whatever I have here, moles of nitrogen, that has to also be down here because I need them to cancel out. So now I've done all the hard work, which to me is setting up. So now all I have to do is read my coefficients from the problem. How many moles of nitrogen do I have? 1. Remember, no coefficient assumption. We assume it's 1. And how many moles of ammonia do I have? 2. My moles of nitrogen cancel like I wanted it to. So now I just do my math. 0.6 times 2 is 1.2. Dividing it by 1 will not change it. So my answer ends up being 1.2. And these are my units, moles of ammonia. Or you can just put moles. You don't have to put necessarily what compound it goes with. Does anybody do y'all have any questions on where any of those numbers come from? All right, let's do one more. And let's do one more here and then we'll look at some. So once again, this is not balanced. So whenever I balance it, I have 4 plus. I'm just rewriting it because of that arrow. 203. So I have coefficients of 4, 3, and 2. Those are my coefficients on that one. All right. So it says the formation of aluminum oxide is from its constituent elements, aluminum oxygen. A bunch of stuff that people put in word problems to confuse you. That doesn't have anything to do with the actual math on this. How many moles of aluminum, so that's my unknown, are needed to form 2.3 moles of aluminum oxide? So that's my given. So in this case, I'm interested in aluminum oxide. I'm not worried about my oxygen. My given is in moles. I have 2.3 moles, and I'm trying to convert that to moles. I'm trying to go from moles of my known to moles of my unknown. So just 2 boxes. Everything today is just going to be 2 boxes. Start with my given, which is always going to be your number from your number from your word problem, and that's moles of aluminum oxide. I'm just going to put ALO. That'll help me still remember what it is without having to write the subscripts. And I'm converting to moles of just plain aluminum. All right, I'm following my units. If I'm moles of aluminum oxide here, what do I have to be down here? Whatever I have here has to be the same thing down here because I need them to cancel out. So you've got to use what you have up there to help you, because then that tells you where to put your numbers. All right, I got it all set up. All I have to do is coefficients. So how many moles of aluminum oxide do I have? 2, perfect. And how many moles of just plain aluminum do I have? 4, that's it. This cancels. I'm left with just one unit, which is what I want. So now, if you want to try it in your calculator, you're going to multiply across. So 2.3 times 4. 9.2, and then come and divide by what's on the bottom. Since it's not a 1, then you're going to have to divide by it. So then you're going to divide by 2. 4.6. And my units are moles. All right. All right, let's look at some on your worksheet. Give you a little head start. What do y'all think? Hard? Not really hard? No? Nobody wants to think about it? All right, let me find the worksheet. All right, here we go. All right, so we'll work through some on these. All right, so here's that same old balanced equation we've seen. So A, B, and C here are all using this. It's already balanced. So when you write the mole ratio, all you're doing is using your coefficients to compare them. So in other words, if I want the mole ratio of nitrogen to hydrogen, I write the coefficient for nitrogen, which is just 1. And then I put a line and I write the coefficient for hydrogen, and I would put a 3. That's not a fraction. That's supposed to be a ratio. You can also write it as 1 with a little colon, I think, and 3. It's just simply the coefficients. And what that tells me is that for every 1 mole of nitrogen, I need 3 moles of hydrogen. I need a lot more hydrogen than I do nitrogen. That's all that ratio is telling me. I'm going to erase that. Okay, so now we'll do the next one. Nitrogen to hydrogen. Nitrogen to ammonia. So what's my coefficient for nitrogen? 1, right? And then you draw your slash. And what is my coefficient for ammonia? 2. That looks like a fraction, but it's not, or you could write it like this. All that's saying is 1 mole of nitrogen gives me 2 moles of ammonia. All right, what would you get for the last one? Hydrogen to ammonia. That's right, 3 to 2, or you can write it like that. All right, so number 2 is doing the same thing, just with a different equation. So y'all can come back to that in a little bit. We're going to move down to 3, and then we'll look on the next page and do some problems. 3 now, I'm using this reaction right here for water. Sorry, Kevin, did you say something or no? Yes. All right, so A just says, what is the hydrogen to water molar ratio? So what would that be? 2 to 2, or you could reduce that down to 1 to 1. All that's saying is that for every 1 mole of hydrogen, they're exactly equal. 1 mole of hydrogen is going to be 1 mole of water. The next one said, suppose you have 20 moles of hydrogen So that's my given. And plenty of oxygen, and all that means is oxygen is not part of this calculation. And you want to see how many moles of water that is. So my given is in moles and my unknown is in moles. So that's going to be 2 boxes. All right, so I start with what I'm given, which is 20 moles of hydrogen, H2. And my unknown, so it's going to go at the top here, is moles of water. What goes down here? What am I looking for down here? Remember, we only would be using 2 things. So yeah, we got whatever's here, which is moles of hydrogen, that has to be down here too. Out of the whole equation, you're only going to do 2 at a time. So now I've done all the hard work. So now I just got to put my numbers in. How many moles of hydrogen do I have in that problem? 2. Remember, Kevin, this mole to mole part where it's mole over mole, that's coming from your coefficients. Okay. Once you use your 20 on that given, then you don't use it again. And then how many moles of water do I have? 2. All right, I set it all up. So now you do your math. 20 times 2 is 40. Divided by 2 gives me 20 again. So I got 20 moles as my answer. So there's some more like that. And I'm going to just skip to the next page and we'll look at a couple of those. All right, so these are balanced for you. So on number 1, you got a balanced equation and you use it for A and B, and that's how it works throughout the paper. So on the first one, it says if 8 moles of magnesium chloride, that's my magnesium chloride, so that's my given, reacts with enough aluminum. If it says something like enough aluminum or that other one, that's oxygen, you're not going to use it in your calculations. How many moles of aluminum chloride are produced? So here's my aluminum chloride. So out of that 1, 2, 3, 4, I'm only using the 2 that I have underlined. And I'm going to scratch out the other 2. All right, it's given to me in moles. And I want to convert to moles, so 2 boxes. So I start with what I'm given, which is 8 moles of magnesium chloride, MgCl. I don't know why this pen is so thick today. And I want to convert to moles of aluminum chloride, this one. Mole of aluminum chloride. Oops, that's not right, is it, y'all? Can't be doing the same thing. I want to find out how many moles. What did I do wrong? I did this one wrong. Y'all gonna just let me keep on going? I put down the wrong given. Change that back to black. That'll make it better. All right, sorry, I'm talking to myself. All right, let's try that again. 8 moles of magnesium chloride, MgCl. And I want to convert it to moles of aluminum chloride. Moles of aluminum chloride. All right, finally. So I follow my units. Since this is moles of magnesium chloride, I have to have moles of MgCl down here. Now I got that mole to mole, so now I'm going to look at my coefficients. How many moles of MgCl2 do I have? 3. And how many moles of AlCl3 do I have? 2. All right. That's all the work. So now I'm going to have to do 8 times 2 because you multiply across. And then divide by what's on the bottom. This one is 3. I got 5.3. Is that what you got? All right. So that's it. 5.3. And your units, well, in fact, your units for everything today are going to be moles. All righty. I'm going to let y'all start working and I will come around. Yeah, like you can do 1 or 2 places behind the decimal. Be fine. And I'll see if anybody needs any help. Do y'all have any questions, my virtual students? Huh? Uh-huh. Uh-huh. Oh. After you get started, they're really quick. Virtual, y'all are good? Okay, thank you, Nancy.